In this lesson, we'll be reviewing how to find the volume of an irregular object by water displacement. And so remember, when we talk about an irregular object, we're talking about an object that does not have size that we can actually measure with a ruler. So for example, if I have a cube, okay, I can actually measure the three sides with an actual ruler. So if I wanted to measure the width, okay, I could do that with a straight edge, a straight ruler. If I wanted to measure the height, then I can do that as well. If I wanted to measure, and so we'll say length and width is the same in this example, I could do that with it. But if I wanted to measure the volume of this rock, then it's going to be a little bit more difficult. So what I would actually need to do is I would need to use water displacement. So let's take a look at what we have. So what we initially do is we start off with a graduated cylinder. And so we fill our graduated cylinder up with a particular amount of water, enough water to where you know that it will cover the object. And so when we write down the initial volume, so whatever that volume is initially, we write it down. So here, our initial volume would be 30 milliliters. But remember, since we're doing volume by water displacement, then what we're going to do is we're going to use 30 cubic centimeters. Okay, so our initial would be 30 cubic centimeters. Now, once we actually place our object, and so our object here would be a rock, we will place the rock inside of the water, and so we would basically tilt it and then let it slide into the water, because we don't want to lose any of the liquid that we've already put into the actual graduated cylinder, because then it will throw our actual calculations off. So now that we've put the rock into the water, then what we have here is we have a new volume. And so our new volume would be 40 cubic centimeters. Okay, so we call that our final volume. This would be our final volume. Okay, so now that we have two different volumes, what we have to do now is we have to actually take the difference between the two volumes. And so remember, even in math class, when we say difference, that means we're subtracting. Okay, so which one are we actually subtracting? Well, we're subtracting our initial from our final. So since our initial is 30 and our final is 40, we take 40 cubic centimeters and we'll subtract our initial, which is 30 cubic centimeters, and the difference of that is 10 cubic centimeters. So the volume of our rock would be 10 cubic centimeters. So just remember that when you're finding volume by water displacement, the first thing you want to do is you want to fill up your graduated cylinder to a certain amount, and you want to record that, what the volume is of the amount of liquid that you put in there. And then the next thing you want to do is go ahead and take your object, put it into the graduated cylinder. Do not drop it in there, because you may actually lose some of the water, liquid might splash out and you'll lose some of your volume. Slide it in there and then record your final volume. And then once you record your final volume, then what you'll do is you'll subtract your initial volume from your final volume, and that will give you the actual volume of the actual object that you were trying to find the volume for. So we would do this even if we needed to calculate density. So basically, if you need to calculate density, remember for density, you need mass of the object and the volume of the object. So if you were asked to calculate the density of something, but you do not, of an irregular object, but you do not know the mass, you would have to weigh it. And then after you weighed it, and then you would have to find the volume. And you can find that by water displacement. Okay? So keep that in mind, and you'll do fine.